Carrying great hopes from NASA, the Dreamchaser spaceplane has yet to take flight. Unfortunately, the primary obstacle preventing its ascent is the launch vehicle itself. NASA and Sierra Space are undoubtedly eager to resolve this issue, as the Dreamchaser holds significant promise for the future, potentially serving as an ideal replacement for what has become the biggest disappointment of the moment, Boeing's Starliner. In this challenging situation, they might need to turn to SpaceX, the long-standing savior of US aerospace efforts. But why is SpaceX the best option? Could this partnership actually happen? And what benefits could this collaboration bring to NASA? The worst spacecraft in history. Perhaps no other vehicle is more deserving of this humiliating title than the Starliner. Over the past few years, Starliner has consistently been a major disappointment for NASA. Despite its $4.5 billion price tag and more than half a decade of development, the spacecraft's first crewed mission ended in failure. Even after finally launching, it couldn't make the return trip. Right now, Starliner remains stranded at the ISS, plagued by issues such as helium leaks, thruster failures, and problems with its undocking software. This situation has led NASA to propose a solution that involves using SpaceX's Dragon to rescue the mission. If Starliner cannot resolve its issues within a month, the two astronauts will be returned to Earth on SpaceX's Crew 9 next year, leaving Starliner to make the trip back without any crew on board. For Boeing, a long-standing company with a reputation for engineering excellence, this is nothing short of embarrassing. It's a mortifying failure for both the company and the expensive crew vehicle. However, this setback could create opportunities for other spacecraft. While the role of SpaceX's Dragon has already been extensively analyzed, this situation presents a particularly significant opportunity for Dreamchaser, the spaceplane poised to emerge as a viable alternative for NASA. Dreamchaser could potentially support or even replace Starliner in the future. But why is this the case? Compared to Starliner, Dreamchaser boasts several strengths that set it apart. Originally envisioned as the successor to NASA's Space Shuttle, Dreamchaser stands out due to its design and unique landing method as a spaceplane, unlike conventional spacecraft. While it's still too early to definitively assess its reliability, the positive results from its test offer more confidence than Starliner has managed to inspire. Though Dreamchaser has been slow in its testing phase, this deliberate pace has allowed for thorough evaluations, helping to avoid the pitfalls that have plagued Starliner. In contrast, Starliner's delays have not yielded the same level of reliability. This careful approach by Dreamchaser could prevent the types of issues that have continuously hampered Starliner. As for Boeing's Starliner, the best it can do is to fulfill the tasks outlined in its NASA contract. However, with its history of countless problems and delays, even that seems uncertain. There's no guarantee that Starliner will be able to perform as required, making any further delays or failures all too possible. Moreover, the possibility of the Starliner project being cancelled is growing. NASA has recently shown a willingness to cancel costly projects as seen with the Chandra telescope and the Viper lunar rover. Both of these projects are arguably as important as Starliner, yet Starliner has been far more disappointing. Even though NASA remains committed to Starliner, going as far as to grant it a crew launch certificate despite its inability to safely return astronauts, there's still a chance it could be cancelled. In that event, Dreamchaser would be a strong candidate to step in. Although NASA could rely on Dragon to take over Starliner's duties, they likely wouldn't want to create a monopoly or become overly dependent on any single organization. This makes Dreamchaser an attractive alternative, allowing NASA to maintain competition and flexibility in their crewed space missions. However, Dreamchaser is not without its challenges. Despite successfully completing testing and being moved to the launch site at Kennedy Space Center, it has yet to take flight. This delay adds another layer of complexity to NASA's options as they consider the future of their commercial crew program. Dreamchaser was originally set to be launched aboard ULA's Vulcan rocket during the CERT-2 mission. However, due to the pressing need for government payload certification, ULA has opted to launch a dummy payload on CERT-2, pushing the Dreamchaser mission to an undetermined date. It's undeniable that Dreamchaser's progress has been somewhat slow. After years of development, its first prototype was only completed at the end of last year. The months-long testing process that followed led to a scheduling conflict with its intended launch vehicle, the ULA Vulcan Centaur. In hindsight, Sierra Space might regret not considering more carefully before partnering with ULA, a company currently undergoing significant changes. As ULA phases out its older rockets and focuses on developing the new Vulcan Centaur, it is under pressure to secure national security launch certification. This urgency doesn't align well with Dreamchaser's pace. Additionally, Vulcan is neither quickly produced nor launched, and it lacks reusability, limiting Dreamchaser's deployment flexibility. This could result in yet another year passing without a Dreamchaser launch, which would be a significant disappointment for Sierra Space, NASA, and the broader aerospace industry. Beyond the current scheduling conflict, Vulcan may not be a suitable long-term partner for Dreamchaser. As ULA's older rockets retire, Vulcan will become its primary vehicle for launching national security payloads. However, due to delays, Vulcan has accumulated a backlog of missions that will take years to complete. With its recent selection for Phase 3 of the National Security Space Launch Contract, running from 2025 to 2029, Dreamchaser's launch plans could be further affected. So, who can save Dreamchaser, Sierra Space, and NASA at this critical time? The answer is none other than SpaceX vehicles. If you agree with my opinion, please respond with yes in the comment section down below. Don't forget to like, share the video, and subscribe to our channel to keep following SpaceX's development journey. NASA would likely be thrilled with this combination as it offers numerous benefits. Compared to ULA, SpaceX vehicles have several advantages. Firstly, SpaceX boasts the highest launch frequency in the world. Falcon 9 in particular has reached over 360 missions, becoming the most frequently launched vehicle in recent years. Falcon 9 can currently handle launches every 2 to 3 days, sometimes even within hours, offering unmatched flexibility to all customers, including Sierra Space. Additionally, Falcon Heavy, though launched less frequently, maintains stability and is ready to step in for Falcon 9 in challenging situations. The reliability of Falcon rockets is also a significant advantage, with a success rate of over 99%. From 2015 to July of 2024, Falcon rockets experienced no major incidents, and even when they encountered problems with the second stage, SpaceX quickly addressed the issue and made a strong comeback. This level of reliability is unmatched by any other rocket or organization. One of SpaceX's most significant competitive advantages is the reusability of its Falcon system. This feature allows SpaceX to save on production costs, which in turn reduces launch costs, a benefit every customer appreciates. Reusability also enables SpaceX to increase its launch rate over time. Their launch rate has consistently risen each year with a goal of reaching 148 flights this year. Therefore, SpaceX is undoubtedly the best option to help Dreamchaser at this time. With frequent launches, flexible scheduling, affordable costs, and unlimited future potential, SpaceX offers everything Sierra Space needs to get Dreamchaser off the ground. With SpaceX's support, Dreamchaser could definitely launch this year, provided it's ready. Not only will the cooperation between SpaceX and Dreamchaser benefit NASA in the near future, but it also holds immense potential for long-term gains. Beyond Dreamchaser, Sierra Space is developing another promising project, the Inflatable Life Module, currently part of the Orbital Reef Initiative with Blue Origin. Given its potential, Sierra Space could eventually create its own space station system, which will be crucial for NASA once the International Space Station retires. In this future scenario, Dreamchaser and SpaceX rockets would continue to play vital roles in supporting NASA's space activities. While some might assume that Dreamchaser would launch on Vulcan or New Glenn as part of Orbital Reef, it's clear that these vehicles lack the reliability that SpaceX rockets consistently deliver. Building and operating a new space station involves numerous challenges, including maintaining schedules and ensuring stable operations. For vehicles that are slow to manufacture and launch, meeting these demands may not be feasible. SpaceX, with its rapid launch capability and proven reliability, is undoubtedly the best option to meet these stringent requirements. The prospect of Dreamchaser launching on SpaceX vehicles is a glimpse into the future of the aerospace industry. This partnership would bring together the world's most reliable launch vehicles and one of the most promising spacecraft in the coming years. And now that moment is approaching. These two giants will join forces to soar into space and achieve remarkable milestones. So, I ask of you, are you ready to witness this historic collaboration? For me, if there's one thing I know to be constant, it's that excitement is guaranteed. In a surprising turn of events, Sierra Space has emerged as the company set to acquire ULA, defying many industry predictions. While not a giant in the space sector, Sierra Space shows significant potential to rival SpaceX in the future. This acquisition signals the end of ULA as we know it and introduces new challenges for the remaining major players in the industry. How is this deal progressing? And what impact will it have on the space race? Could this move position Sierra Space to surpass SpaceX? According to sources, Boeing and Lockheed Martin, the two companies that founded ULA, are currently in negotiations to sell their rocket launching joint venture to Sierra Space. With ULA's current valuation estimated between 2 to 3 billion US dollars, the acquisition appears to be a feasible investment for a relatively young company like Sierra Space. This development is surprising, as Sierra Space was not initially seen as a top contender to acquire ULA. Many anticipated that Blue Origin, especially given Jeff Bezos' significant moves this year, would be the frontrunner. The possibility of a Blue Origin ULA combination had fueled speculation about a fierce rivalry between Bezos and Elon Musk. However, I believe the Sierra Space ULA partnership could be even more formidable, potentially creating stronger competition for SpaceX than Blue Origin could. Do you agree? Are you excited about the potential deal and the future competition between Sierra Space and SpaceX? If so, respond with yes in the comments down below. And don't forget to like, share the video, and subscribe to our channel to stay updated on SpaceX's development journey. Now, let's delve into the details about the parties involved in this significant deal. For ULA, this sale might be the most favorable outcome. ULA has been grappling with significant challenges in recent years, largely due to delays in developing and launching new rockets. Their older rocket families, such as Atlas and Delta, have either been retired or are nearing the end of their operational life, offering little assistance to the company. As a result, ULA has consistently lost ground to SpaceX, leading to the decision to sell the company. Additionally, ULA has been dealing with serious human resource issues. According to BNN Bloomberg, ULA has lost 45 out of 105, or about 42% of its launch operations engineers this year. This exodus has been an ongoing problem for years and could continue into the future. These engineers, who play a crucial role in testing, assembling, and preparing rockets for launch, are critical to ULA's operations. The loss of such key personnel exacerbates ULA's already precarious situation. What's more concerning is that many of these engineers are moving to SpaceX or Blue Origin, ULA's primary competitors. This shift is understandable given that these companies can offer better job opportunities, higher income, stability, and long-term growth potential. This deal could indeed be a game changer for Sierra Space, setting the stage for significant growth and development. While many aerospace enthusiasts are likely familiar with the Dreamchaser spaceplane and the Life Inflatable Module system, it's important to note that the company behind these innovations, Sierra Space, was only established in April of 2021, following its separation from Sierra Nevada Corporation. If this deal goes through, it will provide a substantial boost to Sierra Space. One of the immediate benefits will be the resolution of a critical issue: launch vehicles. Sierra Space currently relies on ULA's Vulcan rocket to launch their Dreamchaser spaceplane. This rocket will also play a key role in deploying and operating their future space station. However, despite Dreamchaser being fully prepared for launch, scheduling conflicts with Vulcan have created uncertainty about whether it can launch this year. While part of the delay stems from slow production and testing of Sierra Space's spaceplane, the dependency on another company's launch vehicle has caused the company to miss several planned milestones. Moreover, renting launch vehicles from other companies incurs significant costs, which is not sustainable for long-term growth. By acquiring ULA, Sierra Space would not only eliminate these scheduling issues, but also gain full control over their launch capabilities, allowing them to operate more efficiently and cost-effectively. It's a strategic move that could significantly enhance their ability to compete in the aerospace industry. Once Sierra Space owns ULA, they will have the ability to launch their spaceplane on their own schedule, a significant advantage given their current situation. The Tenacity prototype is ready to fly in Florida, and they are also producing the second cargo prototype, Reverence, with plans to start production on a third prototype, which will be the first crewed version. Additionally, Sierra Space's inflatable module system has made substantial progress over the past year, highlighted by 2 successful full-scale tests. With the launch schedule for the Orbital Reef project approaching, having their own launch vehicle would greatly streamline their operations, allowing them to meet tight deadlines more efficiently. The acquisition of ULA will also significantly expand Sierra Space's reach. By entering the military and government payload launch market, where ULA holds a significant share, they will directly compete with SpaceX, which has gradually overtaken ULA in recent years. This move could indeed position Sierra Space as a formidable competitor in the industry. However, the acquisition does come with challenges. Integrating a large organization like ULA along with its extensive human resources will be a complex process that requires time and careful management. The task of unifying both companies into a cohesive system is further complicated by the potential resistance from existing ULA leadership, particularly if Tory Bruno, ULA's CEO, is reluctant to relinquish control. Given SpaceX's rapid development pace, any delays in this integration could leave Sierra Space struggling to keep up. The pressure will be on to ensure a smooth and swift transition to fully capitalize on the benefits of this acquisition. Sierra Space will face significant challenges with the Vulcan rocket, even if they acquire it. They'll still depend on ULA's engineering team for effective operation, while their own engineers will need time to adapt to the new system. The Vulcan's lack of reusability is a major drawback, leading to higher costs, increased launch prices, and reduced competitiveness compared to SpaceX's reusable rockets. Additionally, reliance on Blue Origin's slow-to-produce BE-4 engine could further delay launches, especially with the upcoming New Glenn rocket. Although Sierra Space has potential in the government and military payload market, their lack of experience combined with ULA's backlog of delayed missions presents significant hurdles. Managing these challenges will be essential for Sierra Space's success. On the other hand, SpaceX's rockets continue to evolve and perform impressively. The Falcon 9 remains highly reliable even after last month's incident, and is steadily breaking records for both launches and reusability. The Falcon Heavy, while not launching as frequently, maintains its strong track record of reliability. Starship, SpaceX's next-generation rocket, is also making significant progress. Its most recent mission showcased the rocket's full landing capability, a feat no other organization has achieved. The future potential of Starship far exceeds that of Vulcan. When it comes to spacecraft, SpaceX's Dragon continues to set the standard on the ISS. With its remarkable achievements, Dragon has established itself as the most reliable vehicle for NASA and private customers alike across a variety of missions. This is a level of trust and performance that Sierra Space's Dreamchaser will take years to match, despite its promising potential. It's also important to note that SpaceX isn't Sierra Space's only competition. Other companies are emerging as strong contenders. Rocket Lab, in particular, has been impressive in recent years, consistently increasing its launch frequency and making early strides in reusability. I believe Rocket Lab could become a formidable competitor on par with Sierra Space in the near future. Nonetheless, Sierra Space's acquisition of ULA is poised to significantly alter the dynamics of the space race. This deal could redefine competition in the industry, but it will also introduce new challenges that Sierra Space must navigate to capitalize on this opportunity. The end of ULA marks the beginning of a new formidable force positioned to challenge SpaceX. For some time now, there hasn't been a competitor capable of truly pushing SpaceX to its limits. While the challenges I've outlined are significant, the competition on the horizon is promising. SpaceX will likely welcome this new rivalry, as it will provide the motivation to innovate and strengthen its leading position even further. Another key player impacted by this development is Blue Origin. With the unexpected loss of ULA, Blue Origin will have to depend solely on its current assets. Given its current capabilities, if Blue Origin doesn't accelerate its progress, it could find itself outpaced by Sierra Space. For the United States, increased competition in the aerospace industry is a positive outcome. The rise of another strong contender alongside SpaceX will bolster the country's ability to compete on the global stage. We are on the verge of witnessing one of the most significant shifts in the space race in recent years. This new chapter will bring fresh inspiration and is likely to drive major breakthroughs in the aerospace industry. The competition between a well-established dominant company like SpaceX and an ambitious up-and-coming contender like Sierra Space is bound to be fascinating. Are you ready for what's to come? The deadline for Blue Origin's much-anticipated New Glenn debut flight is fast approaching. This mission holds the potential to significantly alter the trajectory of Blue Origin, positioning the company as a formidable competitor in the aerospace industry, particularly against SpaceX. Recognizing the stakes, Blue Origin is intensifying its efforts to ensure everything is in place for a successful launch. But what progress has been made with New Glenn, and could it truly enable Blue Origin to challenge SpaceX's dominance? Last month, Blue Origin caught the world's attention by revealing a test of the landing leg system for New Glenn's first stage. This move indicates that Blue Origin is not only focused on reaching orbit but is also aiming for reusability, a goal that many aerospace companies are striving toward. In August, Blue Origin took another significant step by testing the forward module of New Glenn. According to CEO Dave Limp, this module underwent tests involving its thruster and forward fins, which are critical components of the rocket's operation. The forward module bears a similar appearance to the first stage, featuring 4 fins as described by Limp. During the test, the fins were seen rotating smoothly, though as usual, Blue Origin did not disclose specific details about the test results, leaving the effectiveness of this system uncertain. However, Dave Limp did share some intriguing insights about the module. He noted that the 4 fins on New Glenn are substantial in size, each roughly the size of a car, measuring about 16 feet, or 4.88 meters long at the base and extending 6.5 feet or nearly 2 meters from the rocket's body. These details highlight the scale of Blue Origin's ambitions as they prepare for New Glenn's debut flight. Limp has also officially disclosed details about the materials used in the New Glenn rocket. He stated that most of the rocket's structure is made of aluminum, protected by a durable fabric thermal protection system internally referred to as Comet. He also highlighted the significant aerodynamic forces acting on the fins during flight, comparing them to the weight of a 737 aircraft. These fins are crucial for steering the rocket during both ascent and descent. In addition to the fins, Blue Origin conducted tests on the thrusters of the forward module. The module appears to have 6 thruster areas with varying numbers of thruster holes at each area. The tests demonstrated that the airflows generated by these thrusters are quite powerful. Limp explained that this system corrects New Glenn's orientation in zero gravity and just before landing on a vessel at sea. He emphasized the importance of these thrusters and the forward fins, stating that they are essential to the booster's reusability. Blue Origin is clearly committed to its roadmap, particularly in terms of reusability, even though New Glenn's first flight has yet to occur. Following these tests, Blue Origin recently attracted attention by moving a Pathfinder booster to Cape Canaveral, where it was immediately erected. This step further signifies the company's determination to advance its New Glenn program. This recent activity by Blue Origin likely serves as preparation for an upcoming crucial test, similar to the launch system test they conducted earlier. Blue Origin marked this progress with a tweet, "Port Canaveral spectators got a sneak peek of our recovery operations today, as we demonstrated the process of transitioning New Glenn's first stage from vertical to horizontal using our 200-foot tall simulator. The operation validated our tooling and procedures for recovering our first stage from the landing vessel, bringing us another step closer to our first launch." Following the first stage's operation, another image surfaced, showing Blue Origin rolling another stage. With the prominent Blue Origin logo visible, it is likely the rocket's second stage, which might soon arrive at the launch pad to be stacked on the Pathfinder booster. These efforts are part of a series of preparations Blue Origin has been undertaking this year. Earlier, the main stages of New Glenn were publicly displayed and later mated together. Subsequently, the Pathfinder prototype was rolled to the launch pad and stacked. Last month, Blue Origin tested the launch pad's quick disconnect system with a modification prototype, and they also conducted an important test with New Glenn's first stage landing leg system. The hardware preparations for Blue Origin's New Glenn are nearing completion, with only the BE-4 engines and the fairing containing the payload left to be finalized. According to NASA's schedule, New Glenn's debut mission is tentatively set for October at SLC-36, where it will launch NASA's Escapade Mars spacecraft. This mission, although involving a relatively modest $80 million payload, is crucial for Mars exploration. Choosing such a significant payload for its debut flight underscores Blue Origin's determination to establish its reputation from the outset. Success in this mission could position New Glenn as a strong competitor to the ULA's Vulcan, which launched NASA's Peregrine lunar spacecraft earlier this year. However, Blue Origin's most formidable rival remains SpaceX's Starship. Competing with SpaceX, however, poses significant challenges for Blue Origin. Despite their progress, several issues persist. As the launch date approaches, uncertainty remains about when the rocket's final assembly will be completed. A major concern is the availability of the BE-4 engines, as it's still unclear when the 7 engines required for New Glenn will be ready. Once New Glenn is fully assembled, it will need to undergo several critical steps, including cryogenic tests, spin prime tests, static fire tests, and a wet dress rehearsal. Completing these procedures within 1 or 2 months will be challenging. Additionally, Blue Origin will need to secure a launch license from the FAA, a process that can also be time-consuming. These factors raise the possibility of further delays for New Glenn's debut mission. This uncertainty leads to an intriguing question: which will launch first, Starship Flight 5 or New Glenn's debut? Feel free to share your predictions in the comments section down below with S5 or NG1. Don't forget to like, share, and subscribe to our channel to keep up with SpaceX's development journey. Even if New Glenn stays on schedule, success isn't guaranteed, given Blue Origin's lack of experience with orbital launches. If the launch is successful, the question remains: what will Blue Origin do next? The slow production pace of New Glenn, both in terms of hardware and engines, has already placed it behind SpaceX's Starship, despite both projects being conceived around the same time. In terms of reusability, which Blue Origin has emphasized in recent announcements, I personally find New Glenn's hardware to be quite bulky and rudimentary, raising questions about how they plan to achieve successful landings and reusability. It seems likely that they will need significantly more time to reach these milestones. On the other hand, New Glenn's competitor SpaceX's Starship is making remarkable progress. In just over a year, SpaceX has already launched 4 integrated Starship flights, with the next one planned for late August or early September. This rapid cadence is something that even Falcon 9, currently the most frequently launched rocket in the world, didn't achieve in its early stages. The time between Starship flights has been shrinking notably, from 7 months between Flight 1 and Flight 2 to less than 3 months between 3 and 4. It's unlikely that New Glenn will reach this pace within the next 2 to 3 years. While Blue Origin is still grappling with its future plans, SpaceX is far ahead with ambitious goals for Starship, including launching and landing 44 times per year in Florida, 25 times per year at Starbase Texas, and potentially thousands of flights annually in the future. The second key factor is reusability. In Flight 4, SpaceX achieved a significant milestone by successfully landing 2 stages of a rocket for the first time, something no other organization has accomplished. This achievement lays the groundwork for future goals, such as landing on the Mechazilla arm in Flight 5 or using drone ships for landings. It's clear that competing with Starship is a formidable challenge for New Glenn. Even when compared to other SpaceX rockets like Falcon 9 or Falcon Heavy, New Glenn seems to have little chance of outpacing them. Looking at the broader aerospace industry, Blue Origin and New Glenn might not even surpass smaller competitors like Rocket Lab. Rocket Lab has launched 52 Electron missions, with their launch frequency increasing yearly. In many ways, they have already outpaced Blue Origin by successfully reaching orbit and landing an orbital rocket, a feat Blue Origin has yet to achieve. Rocket Lab is also developing a reusable medium-range orbital rocket, Neutron, which is slated to launch next year. If Blue Origin and New Glenn don't accelerate their progress, they risk being left far behind by many of their competitors. These upcoming challenges will be significant hurdles for Blue Origin and New Glenn despite the extensive preparations they've undertaken. It's truly a case of now or never for them. The time for planning is over. They must quickly turn these preparations into tangible achievements. Having already lost valuable time, they've allowed their competitors to pull ahead. The pressure is mounting as the New Glenn debut mission, which will be crucial in determining their future in the space industry, approaches rapidly. All eyes are on Blue Origin now. Let's see if they can rise to the occasion and deliver when it matters most. Humanity is on the verge of returning to the moon this decade, with Starship set to play a pivotal role in this historic mission. In tandem with Starship, NASA is developing additional systems to support this significant endeavor. However, not all of these systems are proving to be effective, with the Lunar Gateway standing out as a point of concern. The Lunar Gateway initiative is currently encountering several challenges, most notably its potential conflict with Starship HLS. What are the specific issues with the Lunar Gateway, and should NASA reconsider this complex initiative? According to NASA's current roadmap, Artemis 2 is scheduled for September next year, followed by Artemis 3 and 4 missions in September of 2026 and September of 2028, respectively, with both lunar landings being facilitated by SpaceX's Starship HLS, or Human Landing System. Among these, Artemis 3 is particularly significant as it will mark humanity's return to the moon after more than half a century. However, the subsequent missions, especially Artemis 4, the second mission to land humans on the moon, also hold great promise, featuring several major advancements compared to Artemis 3. In addition to Starship HLS, NASA has proposed the development of a system called the Lunar Gateway. This project envisions a space station operating in lunar orbit, serving as a staging point before the lunar lander transports astronauts to the moon's surface. The Lunar Gateway is intended to support long-term, sustainable lunar exploration and may lay the groundwork for establishing permanent bases and extended operations on the moon. However, the situation is not as promising as it appears. The complexity and incompatibility of the Lunar Gateway with Starship HLS have raised significant concerns. A recent report from the U.S. Government Accountability Office, or GAO, highlighted several issues with NASA's plans, underscoring the challenges facing the Lunar Gateway project. The first major issue with the Lunar Gateway is its schedule. Initially planned for 2022, the project has faced significant delays, with key modules like HALO, IHAB, and other subsystems still in development. According to the GAO report, the first launch of the system has been pushed back to at least December of 2027. This delay poses a significant compatibility issue with SpaceX's Starship HLS. While Artemis 3 will not utilize the gateway, Artemis 4 is scheduled for September of 2028, only about 10 months after the earliest possible launch date for the gateway. This timeline is insufficient to ensure the gateway is fully operational and ready to support the Artemis mission. Critical components such as the HALO module and the Power and Propulsion Element, or PPE, need to be launched at least 12 months before Artemis 4 to be fully functional. Another concern highlighted in the GAO report is the cost of the Lunar Gateway project. The estimated cost until December of 2027 stands at a staggering $5.3 billion US. NASA has already spent significant amounts, $1 billion on the PPE module and $1.3 billion on the HALO module. This financial burden places immense pressure on NASA, with no guarantees that the project will remain within budget or operate efficiently once completed. Now, let's dive into the complexity of the Lunar Gateway project, which unfolds in 8 intricate steps. Step 1. NASA will begin by using SpaceX's Falcon Heavy to launch the Power and Propulsion Element and the Habitation and Logistics Outpost. These two modules will be connected in space and then deployed. Together, they will transit to a near rectilinear HALO orbit, establishing the basic structure of the gateway. Step 2. SpaceX will follow up by launching its logistics vehicle, the Dragon XL. This vehicle is an upgraded version of the current Dragon, featuring a larger size and increased thrust. The Dragon XL will transit to NRHO and dock with the gateway, providing essential supplies and equipment. Step 3. SpaceX will then launch a depot into low Earth orbit, or LEO. Several Starship tankers will be launched to deliver fuel to this depot. Once the depot has accumulated enough fuel, the Starship human landing system will be launched and docked at the depot to transfer fuel. After being fully fueled, the Starship HLS will separate from the depot, transit to NRHO, and rendezvous with the gateway. Step 4. NASA will launch the Orion spacecraft carrying 4 astronauts and the International Habitat Module, or IHAB, aboard their SLS-1B rocket. This launch will utilize the Mobile Launcher 2 system and marks a critical step in the assembly of the Gateway and the Artemis mission. These steps underscore the immense complexity and coordination required for the Lunar Gateway project, highlighting the challenges NASA and SpaceX face in making this ambitious plan a reality. Step 5. During the journey to the moon, Orion will separate from the SLS upper stage and dock with the IHAB module, which remains connected to the rocket's upper stage. After docking, the IHAB will detach from the upper stage, and Orion will then tow the IHAB to the near rectilinear halo orbit. Step 6. Upon reaching the NRHO, Orion will dock the IHAB into the Gateway. The crew will enter the Gateway and activate the IHAB module, where Orion will remain docked for the next 17 days. Step 7. 2 of the 4 astronauts will board the Starship HLS, which will then undock from the Gateway, descend to the lunar surface, and land. The astronauts will conduct various activities, including moonwalks, to collect scientific samples over a period of about 6 days. After completing their mission, Starship HLS will ascend back to the NRHO and dock with the Gateway. And finally, Step 8. The crew will transfer the collected science samples to Orion for return to Earth. After securing the samples, the crew will board Orion and begin their journey back home. This lunar mission, involving the Lunar Gateway, illustrates a highly complex process with multiple stages and the involvement of various contractors. Each step introduces potential points of failure, as the success of the mission is contingent upon the flawless execution of each contractor's role. For example, the launch of Orion and the IHAB module will be the inaugural mission for the SLS-1B rocket, adding another layer of uncertainty. In this intricate process, reliance on SpaceX systems such as Falcon Heavy and, to some extent, the Starship is key, as these systems have demonstrated significant progress and reliability. As we've highlighted, these processes will take an extended period to complete, leading to exorbitant costs. To put it into perspective, consider the massive expenses associated with NASA's SLS program before the Artemis 1 mission. NASA is under significant pressure due to decreasing budgets in recent years, a trend that may continue. This financial strain has forced the agency to cut costs on numerous projects, with some even facing cancellation. Given this situation, is maintaining the Lunar Gateway truly the right choice? Moreover, the Lunar Gateway system also complicates the Moon mission, especially with the involvement of Starship HLS. Before diving deeper into this, please like, share, and subscribe to our channel. Your support motivates us to keep bringing you updates on SpaceX's developments. Now, let's compare the sizes. The power and propulsion element and the habitation and logistics outpost are designed to fit within Falcon Heavy's fairing payload, meaning they are less than 13 meters long and less than 5.2 meters in diameter. When combined with the IHAB and other systems, the overall size won't increase significantly. In contrast, Starship HLS is vastly larger, 50 meters long, 9 meters in diameter, with a dry mass of about 100 tons. This mass will increase once Starship HLS is fueled for its lunar landing. The disparity in size and complexity between the Lunar Gateway modules and Starship HLS presents significant challenges, both technically and logistically, for the mission. The Starship HLS being larger and heavier than the Lunar Gateway could significantly alter the Gateway's orbit when docked. Attribute this to the size of Starship HLS and its propulsion system, but it's important to note that NASA selected Starship HLS specifically for its lunar missions. The responsibility lies with NASA, not SpaceX. Debates have emerged about whether NASA should eliminate one of these systems, with some suggesting the removal of Starship HLS. However, this would require NASA to completely overhaul its mission plans. Starship HLS is essential for Artemis 3, which is scheduled before the Lunar Gateway's deployment. Removing Starship HLS would jeopardize not only Artemis 4 but also Artemis 3. Without the HLS, NASA would face significant challenges in finding a reliable and cost-effective alternative, as other options like the SLS project, Blue Origin, or ULA do not currently offer the same capabilities as SpaceX. NASA may need to simplify its approach by potentially canceling the Lunar Gateway. Building and using the gateway for the second moon landing seems overly ambitious. Instead, NASA could focus on Starship HLS, allowing SpaceX to develop launch and refueling systems that are more straightforward and cost-effective. This approach could expedite lunar landings and enable future base construction on the moon without the complexities and high costs associated with the Lunar Gateway. As we approach the second half of 2024, NASA must make a decision soon, especially with China advancing its own lunar plans. Simplicity and efficiency will be crucial for success. Should NASA consider abandoning the Lunar Gateway? Share your thoughts in the comments section down below. Onward to the next chapter. As the launch date for Flight 5 approaches, preparations and procedures are intensifying, promising new milestones. Meanwhile, in Europe, a rocket company faced a setback during a test with their rocket, which was anticipated to compete with SpaceX's Falcon 9, highlighting the challenges of rocket development. In contrast, Falcon 9 continues to demonstrate its superiority, securing a valuable launch contract. We are already in the second half of August, and September, the month Elon Musk once set for Starship Flight 5, is right around the corner. In this upcoming flight, SpaceX will attempt to land the Super Heavy booster using the Mechazilla arm. Recently, SpaceX took a significant step forward by receiving approval from the FCC, which posted the license on its X page. The license is valid from August 18th of 2024 to February 15th of 2025. Under the Purpose of Operations section, the agency states, launch vehicle communications for test flight mission launching from Starbase, Texas. The first stage booster will either return to the launch site or perform a controlled water landing. This means that SpaceX's proposal for catching the booster with the Mechazilla arm has been initially accepted by the FCC at least. What we're still waiting on is a similar decision from the FAA. Despite the absence of a mishap investigation, the FAA has yet to make any significant progress, possibly because they're still evaluating SpaceX's new mission proposal for the next flight. As I mentioned, catching a rocket with the Mechazilla arm is an unprecedented move that will undoubtedly set SpaceX apart from the rest. As for the mission process, Starship will still launch, separate as in previous flights, with the second stage attempting to reach orbit, completing its assigned task, then re-entering and landing in the ocean. But the real difference will come from the Super Heavy booster. After separation, it will be guided back to Starbase. For this to happen smoothly, the engines and grid fins must work in perfect harmony. As the booster approaches Starbase, these systems become increasingly critical for navigation and deceleration. Once it gets closer, the chopsticks will open and the booster will slowly maneuver into position between them. The chopsticks will then close to securely hold the booster in place. A landing rail system will help stabilize the booster. Once secured, the chopsticks will rotate and, with the help of the actuator system, adjust the booster's position to align it with the orbital launch mount before finally setting it down. This is the ideal scenario we all hope to see in the next flight. However, since this is a test, success is not guaranteed. There are numerous risks involved. Engine failure could compromise deceleration, navigation errors could arise, or the chopsticks might not open and close as planned. Even the smallest mistake could lead to a catastrophic disaster, potentially destroying the launch tower, launch pad, and even the surrounding area, which includes several fuel tanks. With that in mind, I sincerely hope nothing goes wrong, and that the attempt to catch the Super Heavy booster is successful, paving the way for a new era in Starship development and the broader aerospace industry. In fact, there are good reasons to have confidence in SpaceX. Firstly, they nearly landed the booster in the ocean during Flight 3, even though it later exploded. In Flight 4, the booster successfully landed, although some issues with the engine remained. These two attempts suggest that SpaceX has gained considerable experience in navigating and ensuring engine stability throughout the flight. Even though a few engines failed in these flights, they generally performed well during startup and shutdown operations. Moreover, SpaceX has been continually upgrading the systems at the launch pad since Flight 4. They've modified the booster quick disconnect system and holding clamps on the orbital launch mount. The chopsticks have also undergone significant upgrades, including the replacement of actuators and various other system tests. Recently, SpaceX conducted successful tests involving the closing, opening, lifting, lowering, and rotating of the chopsticks using the B14.1 prototype. With these preparations, I believe we are on the brink of witnessing a significant milestone in the aerospace industry. As the launch date approaches, SpaceX still has some tasks to complete. The prototype tests need to be finalized, with S30 and B12 having completed their separate tests and preparations, as well as the wet dress rehearsal test still ahead. B14.1 has been rolled back to the production site after completing the chopstick tests, so I expect S30 and B12 to be rolled to the launch pad soon, possibly this weekend or the next. Once these tests are completed, the final preparations will be made, and all that remains is to wait for the launch date. In addition to these technical preparations, SpaceX also needs to coordinate with the FAA to secure launch authorization. Hopefully the FAA will soon provide updates on that. As the launch draws nearer, opinions may vary. Some will trust SpaceX, while others may remain skeptical. But I hope everyone will show their support by responding with the number 5 in the comments. Don't forget to like, share the video, and subscribe to our channel to stay updated on SpaceX's journey, especially the upcoming Starship Flight 5. Now, let's shift our focus to Europe, where we recently witnessed a failed static fire attempt by a German rocket company aspiring to compete with SpaceX. The company in question is Rocket Factory Augsburg, or RFA for short, headquartered in Augsburg, Germany. On August 19th, RFA conducted a static fire test with the first stage of their inaugural rocket at Saxavord Spaceport, located in northern Shetland Island, UK. Unfortunately, things didn't go as planned. In a video released by the BBC, we can see one of the rocket's engines explode violently on one side during the venting process. The fire quickly spread upwards, engulfing the entire aft section of the first stage. Within seconds, the fire intensified, rushing upwards and producing thick black smoke. By the 25th second of the video, the entire prototype and test stand were consumed by flames. The video then cuts to the aftermath, showing the prototype completely burned and the test stand severely scorched. This was indeed a catastrophic test failure, and it marks a significant setback for RFA on their journey toward a successful first launch attempt. Following the incident, RFA posted a statement on X saying, "On Monday evening, RFA conducted a hot fire of its first stage at their launch site at Saxavord Spaceport. This resulted in an anomaly that led to the loss of the stage." Thankfully, the company also confirmed that no one was injured during the process, adding, "The launch pad has been saved and is secured. The situation is under control and any immediate danger has been mitigated." RFA is now working closely with Saxavord Spaceport and relevant authorities to gather data and determine what went wrong. They emphasized that they will take their time to thoroughly analyze and assess the situation. The first stage involved in this test was part of the RFA-1 rocket, which stands 30 meters tall with a diameter of 2 meters and consists of 3 stages. From the video, it's evident that RFA has drawn significant inspiration from SpaceX, with the rocket's appearance resembling that of SpaceX's Super Heavy. The booster is equipped with 9 engines powered by liquid oxygen and kerosene, similar to the Falcon 9. Additionally, RFA employs 3D printing technology in the construction of both the first and second stages, with the goal of making the rocket reusable. Notably, RFA has been considered a front-runner among European startups aiming for an orbital launch. The recent static fire test was a follow-up to a successful test in May, during which the company fired 4 of the 9 Helix engines. For the latest test, all 9 engines were installed, while the second and third stages, having already completed testing, were awaiting launch at the spaceport. It's important to note that the stage used in this test was not a mere test article, but actual flight hardware intended for use on RFA's first orbital launch. This failure has caused an indefinite delay in their first orbital flight, which was previously scheduled for September. The company had planned to launch from the very site where this test took place, a launch pad designed to handle up to 30 orbital flights per year. Despite this setback, RFA remains confident, stating, "We develop iteratively with an emphasis on real testing. This is part of our philosophy, and we were aware of the higher risks attached to this approach. Our goal is to return to regular operations as soon as possible." However, this incident underscores the immense challenges of rocket development. Many companies have attempted to emulate and surpass SpaceX only to encounter failures along the way. This serves as a stark reminder of SpaceX's unparalleled expertise and the difficulty of achieving similar success in the space industry. Meanwhile, SpaceX continues to solidify its position in the aerospace industry with yet another valuable satellite launch contract. This time, South Korea has signed an agreement with SpaceX to launch the GeoCommSat-3 multi-purpose communications satellite to geostationary orbit in the second half of 2027. GeoCommSat-3, also known as Choleon-3, is a 3.7-ton satellite designed to replace the aging GeoCommSat-1, which was launched in 2010. This advanced satellite will feature state-of-the-art payloads that serve multiple purposes, including communications, disaster prevention, maritime safety, and ensuring the safe flight of aircraft. The development of the Choleon-3 began in 2021 with a significant budget of 411.8 billion won, which approximates to $309 million US. This contract further strengthens the collaboration between South Korea and SpaceX, which has been growing steadily over recent years. For instance, South Korea's first robotic lunar orbiter was successfully launched aboard a SpaceX Falcon 9 rocket in August of 2022. Additionally, 2 of the 5 military reconnaissance satellites involved in the 425 project were launched on Falcon 9 rockets in December of 2023 and April of 2024. The remaining 3 satellites are also scheduled to launch on SpaceX vehicles through 2025. This latest deal underscores the reliability of SpaceX and its Falcon 9 rocket, further cementing their reputation in the global space industry. At this point, it's clear that SpaceX's capabilities make it exceedingly difficult for any competitor to match or surpass their achievements. Finally, the end. After numerous setbacks, the departure date for the troubled Starliner spacecraft has been set, regardless of how it will return. In stark contrast to Boeing's struggles, SpaceX is celebrating new milestones with its latest Falcon 9 mission. Additionally, there's a glimmer of hope for the Viper lunar rover, which may be salvaged following NASA's cancellation decision. As of now, the Starliner CFT-1 mission has been docked with the ISS for over 70 days, significantly exceeding initial expectations. The pressing question of when it will conclude has recently been addressed by journalist Eric Berger. While not an official source, Berger has a track record of accurate insights, such as his early prediction of NASA delaying Crew 9 to September. According to Berger's update, NASA has tentatively scheduled Starliner's undocking from the ISS for September 6th at the latest. Specifically, the targeted date for a crewed undock is September 2nd, with an uncrewed undock slated for September 6th. This schedule suggests that Starliner must leave the ISS in early September, with the difference between crewed and uncrewed undocking potentially indicating the spacecraft's current condition. According to Berger's recent revelations, which have a track record of accuracy, the Starliner spacecraft is expected to dock with the ISS for approximately 90 days. This aligns with NASA's previously extended schedule. The pressing question now is whether the 2 astronauts will return on Starliner. As of now, NASA has yet to reach a final decision regarding the Starliner spacecraft. The agency has decided to extend its testing and evaluation period by an additional week, with a particular focus on the spacecraft's RCS, which stands for Reaction Control Propulsion System. This extension reflects the complexity and ongoing issues with Starliner, and while the decision has been postponed, it was expected given the circumstances. The outcome concerning the return of the Starliner astronauts is anticipated to be clarified by the end of August. The tentative return dates are set for early September with two possible scenarios: a crewed undocking scheduled for September 2nd or an uncrewed undocking on September 6th. This timeline will determine whether the astronauts will return aboard Starliner or if an alternate arrangement will be required. We invite you to share your predictions in the comments below. Do you think Starliner will return with its crew on September 2nd, or will the spacecraft undock uncrewed on September 6th? To stay informed about SpaceX's latest developments and future updates, don't forget to like, share the video, and subscribe to our channel. Now, if Starliner returns with crew, we will have little choice but to hope for the safe return of the astronauts despite the numerous risks involved with the spacecraft. Although Boeing and Starliner's performance has been disappointing, the priority remains the safety of the astronauts. If Starliner returns without crew, NASA had initially planned for only 2 astronauts to be aboard Crew 9, freeing up space for Butch and Suni to return early next year. However, recent briefings suggest that if an earlier return is necessary, the 2 astronauts might return on Crew 8, which would then have 6 members due to the absence of pressure suits. To ensure safety, it might be better for them to return on Crew 9, even though this would disrupt the original mission plan. This scenario would alleviate previous issues with ISS congestion. The early undocking of the Starliner would create space for Crew 9 to launch in late September, followed by Crew 8's return. Consequently, the ISS would regain its normal operating capacity, demonstrating that without Starliner, operations become smoother and more manageable. The future of the Starliner spacecraft appears increasingly uncertain following its current mission. Despite NASA's decision to continue licensing Starliner for crewed launches, the spacecraft faces significant challenges. The Starliner 1 mission has been postponed to the latter half of 2025, leading to a compressed schedule for subsequent missions. Given its substantial $4.5 billion development cost, there are concerns that Starliner may only complete a limited number of missions, potentially just 6, under the Commercial Crew program before it is phased out or replaced. The space race is becoming more competitive, with SpaceX's Dragon spacecraft maintaining a dominant position and the upcoming launch of Sierra Nevada's Dreamchaser adding another formidable contender. These developments could further overshadow Starliner, exacerbating its difficulties in securing future missions. As we await further developments, it's crucial to see how Starliner performs upon its return early next month. The spacecraft's performance in the coming weeks will be pivotal in determining its viability and future in the increasingly competitive space exploration landscape. Now, moving on to Falcon 9 and its recent mission, on August 15th at 9 a.m. Eastern Daylight Savings Time, SpaceX achieved another successful launch from SLC-40 at Cape Canaveral Space Force Station in Florida. The mission deployed 2 Worldview Legion satellites designated Worldview Legion 3 and 4 for Maxar Technologies. As is customary for Falcon 9 missions, the first stage landed successfully at Landing Zone 1 approximately 8 minutes after liftoff. This landing marked the 16th successful touchdown of the B-1076 booster, underscoring Falcon 9's impressive reusability record and highlighting SpaceX's continued commitment to advancing rocket recovery technology. During the mission, the Falcon 9's second stage proceeded with its primary task of placing the Worldview Legion satellites into Sun synchronous orbit, or SSO for short. About 46 minutes after launch, SpaceX confirmed the successful deployment of the first Worldview Legion satellite. Just over an hour later, the second satellite was also successfully deployed. This successful deployment marks a significant milestone for the Worldview Legion constellation, which aims to enhance Earth observation capabilities with its high-resolution multispectral imagery. With these deployments, the latest additions to the Worldview Legion constellation are now operational. operational. These satellites were launched into a mid-inclination orbit covering areas between 45 degrees north and 45 degrees south latitude, which includes most populated regions. This orbit allows for frequent revisits over a broader range of latitudes and complements the earlier two satellites launched on May 2nd. The Worldview Legion constellation, consisting of 6 satellites, will see the remaining 2 satellites launched by Falcon 9 later this year. This ongoing collaboration strengthens the partnership between SpaceX and Maxar Technologies. This satellite constellation will significantly enhance Earth observation capabilities. Maxar representatives noted, when all 6 Worldview Legion satellites are launched, it will triple Maxar Intelligence's capacity to collect 30-centimeter class, or 12 inches, and multispectral imagery. The full Maxar constellation of 10 electro-optical satellites will image the most rapidly changing areas on Earth as frequently as every 20 to 30 minutes from sunup to sundown. For SpaceX, this mission marks several notable achievements: the 364th Falcon 9 launch and the rocket's 10th mission since its resumption on July 27th. The pace of 10 missions in 19 days signifies a launch every 2 days. Additionally, this is the 79th Falcon 9 mission and the 80th for the Falcon rocket family this year, a major milestone towards the goal of 148 launches. With 3.5 months remaining in the year, SpaceX's end-of-year activity will be crucial in reaching this ambitious target. Next, let's discuss the Viper lunar rover, which may potentially be rescued from cancellation by NASA. Intuitive Machines, a company that collaborated with SpaceX to launch a lunar lander earlier this year, is now working to keep the Viper mission alive. The company is assembling a coalition of organizations that could assume responsibility for the NASA lunar rover mission, proposing to launch it on one of their landers. Intuitive Machines executives have indicated their intention to respond to a request for information from NASA regarding the takeover of the Viper mission. Steve Altemus, CEO of Intuitive Machines, emphasized the significance of the Viper mission, stating, "Our position is that Viper science is crucial to lunar researchers and the future of the Artemis program. It plays a key role in prospecting for volatiles and entrained water ice in the lunar soil. This potential rescue operation underscores the ongoing commitment to lunar exploration and the strategic importance of Viper in advancing our understanding of the moon's resources." The collaboration between Intuitive Machines and other organizations could provide a critical path forward, ensuring that the valuable scientific objectives of the Viper mission are achieved. In the RFI, NASA outlined that prospective partners would be responsible for final testing, additional work on the rover, delivering it to the lunar surface, and operating it once there. Companies interested in taking over the project must also complete all remaining processes with Viper before it becomes operational. Currently, the rover has finished production and is undergoing environmental testing. If Intuitive Machines successfully takes over the Viper mission, they plan to develop a lander called Nova-D to transport the rover. However, they face challenges in finding a suitable partner for this project and are dealing with financial strains due to substantial investments in the IM-2 and IM-3 missions. Despite these hurdles, supporting Intuitive Machines in this endeavor is crucial. The Viper rover was developed at significant expense, funded by taxpayers, and abandoning it now would be unfortunate. Allowing a company to take over could be a viable solution, potentially opening opportunities for SpaceX, which would likely be the launch provider for Intuitive Machines. The Falcon Heavy, originally selected for the Griffin mission, could still be used to launch Viper. In the end, with or without NASA's direct involvement, SpaceX and Intuitive Machines could continue advancing lunar exploration. Well, folks, that's about it for today's episode. Thank you so much for tuning in, and as always, this has been Kevin from Great SpaceX. Until next time, keep looking up.